Alright, so we're going to look at next is Unit 6, Lesson 6, I guess. I'm sorry, Unit 7, Lesson 6, and we're going to look at more quantitative measurements of concentration. We're going to look at first molarity, and then we're going to look at parts per million. So let's take a look at molarity first. Molarity is a number that tells you how much solute is dissolved in a given amount of solvent. And it's basically the number of moles of solute per liter of solution. And even though it doesn't say this, the symbol for molarity is a capital M, not to be confused with, I guess, M, a small m. Could be considered mass, it could be considered a bunch of different things. The formula for molarity is on table T. It is the moles of solute over the liters of solution. Let's take a look at a couple of questions. I think it's probably the easiest way to get things going here. If you take a look at the question, it says what is the molarity? So first thing you want to figure out is what are they asking you to solve for? So obviously it says what is the molarity? That's going to be your X. That's what you're trying to look for. So they have to give you these two numbers. Now sometimes they make it very easy and they give you the moles and the liters. So it says 4.0 moles. So you have molarity equals 4.0 moles. And they give you the liters. It's 0.5. Oops. 0 liters. A couple of things to keep in mind. If they gave you milliliters, you would have to, of course, convert to liters. So if you remember milliliters to liters, you're going to divide by 1,000. So, 1,000 milliliters would be 1 liter. So just keep that in mind. Milliliters to liters, you divide by 1,000. In other words, move the decimal 3 places to the left. Alright, so let's see what we got here. This is fairly simple. So if you have 4 moles over 0.5 liters, you're going to get 8 as your answer. 8.0 moles per liter or molar solution. Next one, same thing. It says calculate the molarity of 2 moles of HCl dissolved in 500 milliliters of water solution. And I did get a little bit ahead of myself. As you notice, I do that at times. They do give you 2 moles, but they don't give you liters. They give you milliliters. So we have to convert that to liters, which means we're going to divide by 1,000, which means I move the decimal 3 places. So you're going to end up with molarity equals 2.0 moles over 0.5 liters, and 0.5, and that looks like it's going to come out to a 4 molar solution. Alright, so we've gone through those two. Now let's take a little bit of a different path here. As we know, life is not always that simple. So there are going to be times where you're given a molarity problem, but it's not going to be one of those problems where you simply plug in the moles and the liters and you just simply divide. One of the things that they can do is instead of giving you the number of moles of your solute, they can give you the grams of your solute and ask you to convert it. So the first thing you would have to do is converting your grams to moles. So you'd have to find the gram formula mass of your compound. Then you would have to determine the number of moles by using this formula, and then plug those numbers into the formula. So let's quickly take a look here. So it says, what is the molarity? So again, we're looking for the molarity of a solution that contains, it says, 82 grams of calcium nitrate. So the first thing we have to do is we have to find the gram formula mass of calcium nitrate, which means we have to add up all the masses. So we have, and I'm going to do this quickly, we have 40 for the calcium, we have 2 nitrogens, which would be 28, and we have 2 times 3 is 6 oxygens, so it's 16 times 6 would be, that's 36, so that's 96, and if we add that up, we're going to get 6, 15, 16, 164 is the gram formula mass. That's the bottom. So the number of moles would be the mass, which is 82 over 164 grams in a mole. It's obviously going to give us 0.5 moles. So now we have what we need. We go over here and we say, okay, this is 0.5 and this is 2.0. So 5 divided by 2.0, I think the solution is here. It's going to be, yep, 0.25 molar solution. So 0.5, not 5, 0.5 over 2.0 gives me a 0.25 molar solution. Okay. Now let's take a look at the next one. Alright, so it's basically the same question. We have to determine the gram formula mass of Na2CO3. So we have two NAs, each is 23, so that's 46. We have a carbon, which is 12, 3 oxygens, which is 48. So 8 and 8 is 16. That's 8, 9, that's 10. So it comes out to 106 is the formula mass. So the number of moles is 53 over 106. So they are nice again. This comes out to, again, 0.5 moles. So now we plug this in. We're just going to put 0.5 over 0.250 liters. And we're going to get 2.0, as you can see here, as the answer. 0.5 over 2.5. I forgot what it was. 0.5 over 0.25 would give you exactly 2. Okay, so that is the end of this lesson. Just make sure. Yes, it is. Next one will be